Hey y'all, I hope you guys are having a wonderful week. Today we're going to be going over the Unit 1 test review. As always, remember you can stop the video, pause it, come back to it later. You can rewind it as many times as you need to, and you can always ask me questions. Let's get started. So let's get started with these first 4 problems. So these are multi-step equations. Starting off with this side, I want to follow these steps. I want to see if there's anything outside of the parentheses being multiplied or added, and I want to get rid of it. So in this case, I see there's parentheses, so I'm going to be doing something. And I see that 1/2 is being multiplied by everything inside the parentheses. So I want to get the parentheses by itself by getting rid of this. How would I do that? You could either divide by 1/2 on both sides, or you could multiply by 2, which is the same thing as 2/1, which would cancel it out. So I'm going to multiply the other side by 2/1, which of course is going to give me 52. And then I'm left with the parentheses on this side. Well, everything inside of it. The next step is to combine like terms. There's nothing on this side that can be combined because this one has a variable and this is a constant and this one is by itself. So I can't combine like terms. The next step would be to get rid of constants on the same side as the variable. So on the same side of the variable, I see I have the constant positive 12. To get rid of that, I have to do the opposite of whatever this sign is in front of it. So in front of the 12, I have a positive sign. To get rid of that, I would subtract. But we believe in justice, so what we do to one side, we have to do to the other. So these are going to cancel out, and I'll get negative 4x is equal to 52 minus 12 gives me 40. My next step is to get rid of any coefficients. So with the variable, I see it has a coefficient of negative 4. So to get rid of that coefficient, I have to do the opposite of what's happening. So right now, x is being multiplied by negative 4. So I have to divide by negative 4. But what we do to one side, we have to do the other. So now I'm left with x equals 40 divided by negative 4. Remember, a positive divided by a negative is going to give me a negative. 40 divided by 4 is 10. So x is 10. The next step, we have 6n plus 40 equals 2n. I'm checking to see if I have any parentheses, which I don't. Can anything be combined on the same side? No. So this one is a variable and this is a constant, meaning these are 2 different kinds of numbers, and then this side is by itself, so nothing can be combined. The next step is going to be to get rid of any constants on the same side as the variable. So I have positive 40 right here, and I have 2n over here. I don't necessarily want to get rid of this one because I have a variable over here anyway. So what I'm going to do is I'm going to subtract 6n from this side because I want to get the number by itself and I want to get the variables over to the other side. So what I'm going to do is subtract 6n. But what I do to one side, I have to do to the other. So now I'm left with 40. And 2n minus 6n is going to give us negative 4n. And remember, the reason why I subtracted this variable over to this side is because I want to get all of the variables on one side and all of the constants on one side. So it didn't matter which order I went in. I just wanted to get them on opposite sides. So now I have 40 equals negative 4n. Easy enough. I get to skip to the part where it says get rid of any coefficients. So n is being multiplied by negative 4. So to get rid of that coefficient of negative 4, I'm going to divide by negative 4. But what we do to one side, we have to do to the other. So I'm going to divide the other side by negative 4. So we'll be left alone with n equals 40 divided by negative 4. So we have negative, so a positive divided by a negative is negative. 40 divided by 4 is 10. So n equals negative 10. So these almost happen in the same way, but you see how different the problems were? Let's move to the third problem. So I want to see, are there any parentheses? No. Are there any terms that can be combined? On this side, I have a variable and a constant, so those two can't be combined. But on this side, I have a variable with a p, variable p, and then a constant. So these two are like terms because they both have the same letter p. So I'm going to combine those. So p minus 1 equals, and then 5 is positive, plus 3 is going to give me 8p minus 8. The next step, I want to get rid of any constants on the same side as the variable. Since I have variables on both sides and constants on both sides, what I want to do is I just want to choose a side to get all the variables and choose another side to get all the constants. So I'm going to put all of the variables on this side and all of the constants on this side. But it doesn't matter which order you go in, so I'll actually do both. So if I want to get all the variables over to this side, so p minus 1 equals 8p minus 8. If I move the variable over here, I'm going to subtract 8p to cancel it out, and I'll do the same thing on the other side. So I'll be left with negative 7p minus 1 equals negative 8. And then I'm going to move the constants over to that side. So I'm going to add 1. So now I'll be left with negative 7p equals negative 7. Then I want to get rid of my coefficients. So I'm going to divide by negative 7. And I'll be left with p equals positive 1. If I did it the other way, so p minus 1 equals 8p minus 8. If I got all the variables onto this side and all of the constants onto that side, that would work also. So instead of doing the whole 8p like I did, I'm going to get rid of p on this side. So those would cancel out, and I'd be left with negative 1 equals 7p minus 8. And then I want to get all the constants to the other side. So I'm left with 7 equals 7p, divide both sides by 7, and I get 1 equals p. So I got the same exact answer. The only difference is that I chose to move 1 over to the other side in this one, and then I chose to move it in the opposite direction this side. So it doesn't matter which side you put the variable or which side you put the constant. All that matters is that you combine them correctly. And lastly, we have this big old one. So this one is another large multi-step equation. So in this case, I want to see, are there any parentheses for me to distribute things? And in this case, yes, this is happening twice. So positive 10 is going to distribute, and negative 5 is going to distribute. So I'm going to go ahead and I'm going to distribute them in because there's so many steps. So I have negative 11 plus 10x. So 10 times x gives me 10x, and 10 times 10 gives me 100 equals, and then I have 4, and then 5 times, or negative 5 times 2 is going to give me negative 10x. Negative 5 times positive 11 is going to give me negative 55. So now I want to combine like terms. So on this side, I'll have 10x equal 10x, and then negative 11 plus 100 is going to give me positive 89. And then I'm going to put negative 10x right there. 4 minus 55 is going to give me negative 51. So now I want to get all of my variables to one side and all of my constants to the next side. So I'm going to put all of my constants on this side. So these two are going to cancel out, and I'll have 20x. And then I'm going to get all the variables over to the other side. So minus 89, minus 89. And I get 20x equals negative 140. So now I want to get rid of my coefficients. So x is being multiplied by 20, so I'm going to divide by 20. But what we do to one side, we have to do to the other. So now I'll get x equals negative 140 divided by 20 is going to give me negative 7. Let's move to inequalities. So now we have x divided by 3 is greater than negative 6. This is one step. I see x is being divided by 3. So to get x by itself, I'm going to multiply by 3. But what we do to one side, we have to do to the other. So I'm going to multiply the other side by 3. So these are going to cancel out, and I'll get x is greater than negative 6 times 3 is going to give me negative 18. Then we have this one with parentheses. So I'm going to start off with distribution. So negative 6 is being multiplied by everything inside of the parentheses. So negative 6 times 6m is going to give me negative 36m. And negative 6 times negative 7 gives me positive 42. And then is less than or equal to negative 138. Ooh, that was ugly. So now I want to get rid of any constants that are touching the variable. So I see positive 42. So 42 is being added to negative 36m. So I want to get rid of that by subtracting 42 on both sides. So now I'll get negative 36m is less than or equal to 138 minus 42 is going to give me 180. So negative 180. So now we want to get rid of the the coefficient that is touching the variable. So negative 36 is being multiplied by m. So I'm going to divide by negative 36. But that rule that says if we multiply or divide by a negative, we flip the sign. So I'm going to change the direction. So now I'm going to have m is greater than or equal to, and then negative 180 divided by negative 36 is going to give me 5. So m is greater than or equal to 5. So now we want to see which of the following is not in the solution set for the following inequality. What this means is which one is not going to be a solution. Which one is not going to make this true. So let's show how to do that. Our first step, we don't have any parentheses. We can't combine like terms, but we can get rid of the constants that are touching the variable, or the constants that are being added to the variable. We want to get all of the constants on one side and all the variables on the other. So since this is the only variable, I'm going to keep it. Since this one can be moved over here, I'm going to do that. So the opposite of positive 4 would be negative 4. To get rid of positive 4, I'm going to subtract 4. But what we do to one side, we have to do to the other. So now I'm going to be left with 2x is greater than 20. So now I can get rid of the coefficient by dividing. But what we do to one side, we have to do the other. So now we'll get x is greater than 10. So when it asks which one is not in the solution set, it's going to say it means we plug in for x and see if it makes it true. So is 10 greater than 10? No. But let's keep checking. 11, is that greater than 10? Yes. 15, is that greater than 10? Yes. 24, is that greater than 10? Yes. So the only one that makes it not true is 10. So our answer is A. 10 is not greater than 10, so it's not a part of the solution set. So now it wants us to solve for p, meaning it wants us to get p by itself. So to do that, I'm going to start off with distribution. Distribution is the first step. So I see there's parentheses right here, and it's being multiplied by 3. Whenever we don't have a coefficient, we can assume it's 1. So 3 times 1p is going to give us 3p, and 3 times negative 3 is going to give me negative 9. And then we bring down the rest. The next step is to combine like terms. So I see over here, I can combine 3p and negative 5p, and then we have a constant of negative 9. And over here, we can't combine either of these. We have a variable and a constant. So I'm gonna add 3 and negative 5. 3 minus 5 is gonna give me negative 2p. And then I'm just gonna bring down the rest. So now let's keep solving. So we wanna get all of our variables to one side and all of our constants to the other side. So I'm gonna move the constants to the left, to the right. So over here I have negative 9. To get rid of it, I'm gonna add 9, and I have to do that to the other side as well. So I'm gonna be left with negative 2p is less than negative p plus 3. And now I wanna move this variable over to the other side. So I'm gonna add p on both sides. Negative 2p plus p is gonna give me negative p, so negative 1p is less than 3. So now I want to get rid of any coefficients by dividing by negative 1. But remember, if we multiply or divide by a negative number, we have to flip the sign. So now I'm gonna have p is greater than 3 divided by negative 1 is gonna give me negative 3. So p is greater than negative 3. So now we wanna see which of these is in the solution set. So which of these is true? And we're gonna circle all of the ones that apply. So we have p is greater than negative 3. Let's rewrite it, but plug in these numbers for p. So we have negative 3 is greater than negative 3. Negative 3 isn't bigger than negative 3. It's the same size. So this one is not gonna be. 0, is that greater than negative 3? I know sometimes people are confused because we see the 3 there, but remember, if we had a number line, we would have 0, 1, 2, positive 3, and then back here we'd have negative 1, negative 2, negative 3. So negative 3 is less than 0. So 0 is in fact greater than negative 3. So this is an answer. Then we have positive 3. Is positive 3 greater than negative 3? I see over here, negative 3 is bigger than, or 3 is bigger than negative 3. So this one's true. And then it's 10 a bigger number than negative 3? And the answer is yes. So all 3 of these are in the solution set. Let's move on to literal equations. So literal equations, remember, those are the ones with more than one variable. So in this case, we have A equals BH, and it says it wants us to solve for B. So that means it wants us to get B by itself. So that's where knowing those rules comes in handy. So I see B is being multiplied by H. So to get rid of the H, I'm going to divide by H. But what we do to one side, we have to do to the other. So that would get B equals A over H, which is the same thing as B equals A over H. So either one of these would be correct. The only thing is you have to get B by itself. So now it wants us to solve for W. So we want to get W by itself. So we have to get rid of anything that's being added or subtracted, and then we have to get rid of any coefficients. So right now we have 2L being added to 2W. So I'm going to get rid of positive 2L by subtracting it. But what we do to one side, we have to do to the other. So now I'll have P minus 2L equals positive 2W. So now to get W by itself, the last step is to get rid of its coefficient. So right now it's being multiplied by 2. So I'm gonna divide by 2. But what we do to one side, we have to do to the other. So these are gonna cancel out, and I'll get W equals p minus 2l divided by 2. You could also see this as 1/2 of p minus l equals w. Either one of these would work if you simplified, but this one is probably the more common answer. So now we have 3x minus 5y equals 20, and it wants us to get y by itself. So I'm going to get rid of any term that's being added or subtracted to the term with y. So negative 5y is one term, and 3x is another term. So I have to get rid of 3x because it's being added to negative 5y. So to get rid of positive 3x, I would have to subtract 3x, but I have to do that on both sides. So now I'll have negative 5y equals 20 minus 3x. My last step is to get rid of any coefficients. So y is being multiplied by negative 5, so I'm going to divide by negative 5. But what we do to one side, we have to do to the other. So I'm going to divide the other side by negative 5. So I'll be left with y equals 20 minus 3x divided by negative 5, or y equals 20 divided by negative 5 would be negative 4, minus 3x divided by negative 5 would give me positive 3/5 of x. So either one of these would work. Next, we have the question, the perimeter of the triangle below is 48 centimeters. Determine the value of x and the length in centimeters of the longest side. So it wants us to find the value of x and the length in centimeters of the longest side. So that means first we're going to find the value of x. So we're going to solve for x. I know that the perimeter is 48 centimeters, meaning that if I add up all three of these sides, I would get 48. So I'm just going to say all of these things added up together equals 48. So let me rewrite it. So 14 minus x plus 2x plus 8 plus 3x plus 6. So I have all three of these sides added together equals 48, the perimeter. So now I want to combine like terms. So I'm going to combine all of the terms with x, and I'm going to combine all of the constants together. So I'm going to add 14, positive 8, and a positive 6 together, which is going to give me 28. And I'm going to add negative x plus 2x plus 3x. So 3x plus 2x minus x. So that's 5 minus 1 would give me 4x. So now I want to get the constants all over to one side and the variables over to the other side. So the only thing that can be moved right now is 28. So I'm going to subtract 28 since this is positive, and I'll be left with 4x equals 20. My last step is to get rid of the coefficient. So right now x is being multiplied by 4. So I'm going to divide by 4. So I get 5 equals x. So x equals 5. So I've solved for 5. So I already know I can eliminate all of these answer choices, and I know what it's going to be. But I just want to plug this in anyway. So for the longest side, I don't know if that's this one or this one. Let's see. So 5. So I'm going to plug in 5 for all of the x's. So 3 times 5 plus 6 and 2 times 5 plus 8. So I just plugged in 5 where the x is. So since 2 is multiplying by x, it's going to be 2 times 5, which would give me 10 plus 8. So this side equals 18. Then I have 3 times 5 gives me 15 plus 6 is going to give me 21. So the longest side is 21. Just in case you wanted to see what this side was, 14 minus 5 would give me 9. So our last question. Milan and Angelise solved similar equations but did not know how to interpret their work. So let's look at what they got. So Milan started off with 2 times x minus 5 plus 3x equals 5x plus 6. As he solved, he ended up getting negative 10 equals 6. Negative 10 can never equal 6, meaning that no matter what value you plug into x, nothing is going to make this true. So that means there are no real solutions. If you have two things that cannot ever possibly be correct, that means there's no solutions. No solution for x could ever make this true. For Angelise, she started off with 2 times x minus 5 plus 3x equals 5x minus 10. And so for this one, she ended up with negative 10 equals negative 10. For this one, no matter what value I plug into x, negative 10 will always equal negative 10. It doesn't matter what x is. All solutions would, or all numbers would be a solution. So for this case, all real numbers. So if you ever get a problem where you're left with a number equals itself, that means all real numbers will be solutions. If you ever end up with two numbers that don't actually equal, then that means there's no real solutions. So Milan should not have canceled out 5x on each term. No. Angelise did not apply the distributive property correctly. 2 times x, 2 times negative 5 is negative 10. That's not correct. So far, Milan's equation has infinitely many solutions, and Angelise's equation has no solution. So she actually has infinitely many, and he has no solutions. So that one's not correct. Angelise has infinitely many solutions. True. Milan has no solution. True. And I realize I didn't cover A enough, so I just want to show you what that looks like. So they're talking about in step 3, when he had 5x minus 10 equals 5x plus 6. I want to get all the variables on one side, so let's say I subtract 5x on this side. That would cancel both sides out. So he actually did that correctly. Where it says she didn't distribute correctly, that means, so 2 times x minus 5. 2 times x would give me 2x. 2 times negative 5 would give me negative 10. She did get that, so she did that correctly. So again, our answer would be D. Because negative 10 is always going to equal negative 10, Angelise will have infinitely many solutions. And because Milan's answers would never be correct, negative 10 will never equal 6, that means there's no solution.